In this video, we're going to take a look at fraction notation. And fractions are kind of nice numbers to work with because they're just ratio of regular numbers. Numbers that we know we can work with, like integers. And so, because they're integers, we can do certain things with them like we can integers. We can add them, we can subtract them, we can multiply, and we can divide them. But what I've found, at least in my studies, is that the more I know about fractions, the less I rely on a calculator. And so as you move through fractions, just keep an eye on that goal of like, I can remove myself from the calculator. It no longer has to rule my life. Okay, and that's what we're going to kind of develop, is a feeling for how things should end up. But in order to get there, let's go ahead and take a look at what makes a fraction a fraction. Okay, first things first. Let's talk about what it means, or at least the way a fraction looks. And a fraction is split up into two things. Since it is a ratio, we're talking about one integer divided by another. It's just not done. And so the top integer is called the numerator, and the bottom integer is called the denominator. Later on, when you get to rational functions, then we can still refer to it as the numerator and denominator, even though they won't look like integers. Another way to look at it, a more practical way to look at it, is to examine it as the number of parts that you want. And so if you want to think of it as pieces of pie, say I want that many pieces. That's what goes on top. Now, what goes on the bottom is the number of pieces in the entire thing you're talking about. And so if you're talking about there are 16 out of every 100 people like vanilla ice cream. Sorry, you vanilla fans, but I just made it up on the spot. So the parts that you want, the parts you're concerned about, are the people that like vanilla ice cream. That's 16. But the parts in the whole, the entire population looked at was 100. There were 100 people in the whole population. And so that demonstrates the difference between what you want versus what's in the whole. I'll give you a couple more examples on that a little later. If you're already familiar with fractions, a little bit more detailed oriented introduction then would be considered down here in the white. And all this is saying is the exact same thing I said up here. Fractions are ratios of integers. The integers, represented by script z, are all of the natural numbers, 1, 2, 3, 4, 5, 6, 7. Their opposites, -1, -2, -3, -4, -5, -6, -7, blah, 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 on backwards, and the number 0. And that comprises the integers. The fractions, or the rational numbers, are script q. Q meaning quotient in this case. And so the quotients are represented by a ratio of a to b, such that a and b, those two numbers, are integers, and b is not equal to 0. b is not equal to 0. And so that's a crucial thing when working with fractions. The bottom can't be 0. We don't like that. And that's because what you're telling me is you want a part of something that doesn't exist. There are no parts in the whole. So if you can kind of think of it as pieces of pie, you want a piece of pie, but there's no pie to be had. And so you really can't, you're really not making a choice. You can't have pie, sorry. You'll have to bake your own. Now, in keeping with, of course, the rules of mathematics, there are some fundamental rules here as far as what to keep in mind when you're working with fractions. The first is if you have any number could be positive or negative, doesn't matter, but any number divided by itself is 1. Now, for a little bit more advanced, you're talking about the multiplicative inverse and the multiplicative identity. And so if you multiply a number by its inverse, you get the identity. That's this, as long as a isn't 0, because a does not have a multiplicative inverse. So the bottom can't be 0, but any number divided by itself is 1. Positive 1, always, forever and ever and ever, amen. The second rule is any number divided by 1 is that number. Again, this is an application of the multiplicative identity, that you can multiply any number by 1 and get that number back. It just so happens that 1 as a fraction is 1 divided by 1. And so you just get the number back. This is very, very nice when you're multiplying and dividing, adding, subtracting fractions to be able to go this way. You want to go kind of backwards. There's no real backwards to an equality, but most people like to read it from left to right. So you're kind of going backwards. And that's handy. So you want to make sure that you can go either way with these. Number 3, if you try to divide a number by 0, it is known as undefined. You can't. Cannot happen. You're not allowed. It doesn't make sense. So I can't have a number of pieces of something that isn't there. It just doesn't make any sense. Number 4, though, flips it and says if you take 0 and divide it by any number that is not 0, you get 0. In other words, I have a pie in front of me. It's 4 pieces of pie. However, I choose not to have any. I can still see the whole pie. I still see 4 parts of the pie. I just don't want any of the parts. And so that's 0 out of 4. It's 0. You just don't get any pie. It's not quite the same as you can't have any because there's none there to have. So that's a good introduction into fraction notation and what it means. The faster that you can get these two things in your head as far as numerator to denominator and what it means physically, the easier fractions will be and the easier that problems will be that use fractions.